Unit 3 test review, problem number 1. These problems can look very, very ugly and they can be pretty daunting at first glance. But let's do this first. Let's rewrite the numerator by factoring out a 6x squared. And when we do that, we get x minus 1. Factoring the denominator, we get x cubed as a common factor. So we're going to factor out an x cubed and we get x plus 5. Now, we're going to go ahead and, we'll do this again. We're going to go ahead and continue to factor, and we're going to factor the denominator here. Ooh, this denominator factors, we factor out a 2, we get x squared plus x minus 20. And so in factoring out a 2, we also see that the remaining polynomial factors, and we get x plus 5 times x minus 4. Okay, so this is like about as much work as you'll ever do in one problem. In this numerator, we're going to factor out a 3, and we're going to be left with x squared minus 5x plus 4, which factors the remaining polynomial factors, x minus 4 times x minus 1. All right, so once you've gotten that, then you can list the restrictions here. This first factor, x cubed is not allowed to equal 0, so x is not allowed to equal 0. X plus 5 can't be 0, so you get x is not allowed to equal negative 5 as well. And we've already taken care of the negative 5, so we don't list it again. And then this other factor of x minus 4, if x minus 4 is 0, it's only going to be 0 if x is 4. So x cannot equal 4 as well. Now we're going to rewrite the whole thing, 6x squared times x minus 1 over x cubed times x plus 5. And the reason why we're rewriting the whole thing is because we see this division symbol. And division means invert and multiply. So we're going to multiply, you're going to write it as a multiplication problem, and we're going to invert the second fraction. So the denominator becomes the numerator, and the numerator becomes the denominator. Don't cancel anything yet. That's a big mistake if you do that. Now, the only time you can start canceling is when we have a multiplication symbol, but before you do that, you have to look at this new denominator, and this new denominator could possibly have some new restrictions for you. So you must look, and you see we've already gotten the x minus 4 taken care of, so x can't be 4. We already knew that. But here we have a new factor down here of an x minus 1. That was never listed before as a denominator. So now that it's in the denominator, we see that x is not allowed to equal 1 as well. So if you have a division symbol, basically whatever makes the numerator or denominator equal to 0 is a restriction on what x can be. Now we can go ahead and cancel any factor from the top that's the same as on the bottom. And the reason why is because when you take any number and divide it by itself, it becomes 1. So we'll start with the easier of the two. So x plus 5 over x plus 5, that we can just replace those factors with a 1. The x minus 4 over the x minus 4, again, replacing those factors with a 1. And then we have x minus 1 over x minus 1. Those factors can be replaced with a 1. And then we have x squared over x cubed. So let's go ahead and rewrite this. We're going to take everything that's remaining and we're going to rewrite it so you can see what is going on. We have a 6, we have an x squared, and we also have, we have a 2 right there as well. And then we have an x cubed, and we have a 3. So to see why the answer is what it's going to be, I'm going to go ahead and rewrite every single factor in the numerator completely factored. So in other words, we rewrite the 6 as 3 times 2, and we're going to rewrite the x as x times x, and we still have that 2. And then down here we have x cubed that can be rewritten as x times x times x, and then we have that 3 down there as well as another factor. So this is when it becomes way easier to see what you can cancel, because again, anytime you have one factor up on the top of in the numerator as well as the denominator, you can rewrite those factors by canceling them out and rewriting them as replacing them with a 1. So 3 divided by 3 is 1, so we're going to rewrite it in a more simple way, and that would be just 1. X divided by x, those cancel. X divided by x, those cancel. And again, every time we cancel factors, we get to just replace them with a 1, because 1 times anything is the same thing, and anything divided by 1 is the same thing. So the only factors that don't get canceled are the 2's up on the top and the x down on the bottom. And therefore, 4 over x is our simplified version of that entire division problem, 4 over x. It's amazing that all of that cancels down to 4 over x, but it does.